Dear students, in our previous lectures, we understand about the subject, soft computing. In the second lecture or third lecture, we understand about the concept of biological neurons and how the concept of biological neuron has been used to develop a mathematical model. We also understand the definition of artificial neural network. We established the analogy between the human brain and the brain like a computer. Simulation of human brain. We discuss about that. The task of artificial neural network is not to simulate a complete human brain. The task of artificial neural network which we are going to design or which we are going to program is what? To design a neural network to solve the particular task. And mind it, every problem cannot be solved by artificial neural network. So we have to, first of all, we have to decide that what kind of a problem we are going to solve by using the artificial neural network. In today's lecture, we will understand about the various type of artificial neural network. Why this is important to understand the type of artificial neural network, because as I told you, the structure of neural network, artificial neural network, will be decided on the basis of the problem on which we are going to apply artificial neural network. So it is important to understand that what kind of a artificial neural network should be used to solve the particular problem. Alright guys, so the contents for today's lecture is features of ANN, problem with the ANN, network topologies, different network topologies which can be used to solve the problem, advantage and disadvantage of ANN, application of neural network. That's very, very important. On which kind of a domains we can apply the neural network. All right. It's very interesting to discuss the feature of ANN. Let's discuss. We'll spend a couple of minutes over here. ANN computations are not programmed. Very, very powerful subject. Statement rather. Not programmed means then how they solve the problem? Rather they learn to solve the problem. As we were establishing an analogy between the growth of child and the artificial neural network. In the same way, see, when the child learn about the learning or alphabets or speaking, so it's not like that the parents are writing a program on a child's brain. From where the child is learning? It is learning from the environment. So that is why this is a very important feature of ANN, which we have to simulate. Next, no explicit memory is there. We have already discussed. There is no explicit memory is there in human brain. Then we discuss how the memorization happens through the synaptic weight, synaptic strength. Importance of input depends on their weights. Why? See, it is a strength or weight of the signal which will decide that the next neuron for which it is passing the signal will be on excited state or in inhibited state. Very little computation is required at the level of individual neuron. Input arriving at node are transferred accordingly to the activation function. We will see that in the next lecture why the use of activation function is important. ANN can model any degree of nonlinearity. So it is suggested that when you are applying ANN to solve the problems, the problem should have a nonlinear in nature. If linearity is there in nature of the problem, then there is no need to apply the neural network. It can be y is equal to fx function can solve a problem. So if there is nonlinearity is there in the problem, then only that problem is suitable to apply the neural network. ANN does not require a prior knowledge. There is no need. See, if child is coming on earth, the child is not having all kind of a knowledge. Who is my parents? Which language I have to speak? If the child is in India, in the northern part of India, he or she will speak in English. He is in southern part of India, he or she will speak a different language. So it is not coming by birth. The child is getting from the environment. ANN can handle incomplete and corrupt data also. Why this feature is there? See, sometimes as a human brain, we have a tendency that in spite of the complete picture is not there, we establish the analogy of the particular situation. So same way that this feature is carried from the human brain. ANN is a fault tolerant. ANN can prove massive parallelism there because these all properties has been taken from the attributes or features has been taken from the simulation of human brain. We are trying to simulate a mathematical model which is very near to human brain, which can solve the particular problem like human is solving. So all the features which are there in human brain has been features of ANN also. All right. So nothing is complete, as it has an advantage or the good feature also, then it has a problem also. Problem with neural network. Size. That's very, very important. And friends, let me be very clear, there is no solution at all. Only experimenting knowledge, doing more experiment is a solution. Size of ANN, how many neurons will be there in a total? How many layers will be there? 1 layer is sufficient, 2 layers are sufficient, 3 layers are sufficient. Nobody can say. It depends on the problem for which you are designing a neural network. Training time may require, large CPU cycles may be required. Sometimes, if you see that some childs learn very quickly, they have a good IQ. Some childs are slow learners. That is how it depends on the problem. If you design a neural network, sometimes, let's say neural network is may learn in 1 hour, or it may require 100 set of already inputs are there to learn, or some neural networks are required more than 1,000 cycles also. Cannot predict exact output. This is very, very important. Then for what we are solving? We are saying that there will be no y is equal to fx kind of situation. The function is there, and input is passed to x as input, and the solution y is given. If this situation is there, we want to exact solution, then we have a linear function over there. There is no need to use the artificial neural network. Then the problem which we are going to solve by applying a neural network does not require the exact solution. So ANN does not predict the exact solution means what? It will bring you very near to the solution. And that is also very, very important, because the problem which we are going to solve are very critical in nature. So even approaching near to solution is also very, very important. ANN is an erratic behavior. What is the meaning of erratic behavior? For example, if you are a teacher or you are a parent of you are teaching your sibling also, sometimes you teach your sibling for 5-6 days, and 7th day the child commits the same mistake. Same thing may happen over here also. You pass 100 inputs to train 100 set of knowledge to the ANN, and you think that ANN is perfect now. Now what happens? Once you pass in next input to check that the ANN is trained or not, and suddenly you feel that it is giving you wrong output. So that is why I am saying that erratic behavior. Alright? What are topologies are there? Which in our syllabus, there are 2-3 more topologies are there, but these 2 are in our syllabus. Feed-forward neural network, feed-backward neural network. We will discuss in detail in next slides, right? Okay, feed-forward neural network. If you see the picture, the structure over here, inputs are there, input layer is there, and the last output layer is there. In between, 3 layers are there. Layer 0, layer 1, layer 2, layer 3. So layer 0 is called input layer, layer 4 is called output layer, and all the layers in between layer 0 and layer 4, that is input layer and output layer, are called hidden layer. So layer 1, 2, 3 are hidden layers. So why it is called feed forward neural network? So let us discuss. See, layer 0 pass its output to the layer 1 neurons, and each neuron of layer 0 is passing its output to all the neurons of layer 1, and same thing is happening between the layer 1 and layer 2, and again same thing is happening between the layer 2 and layer 3, and finally between the layer 3 and layer 4. And one more observation is there. There is no interconnection between the neurons of a same layer. So if this kind of a topology is established, this is called feed-forward neural network. Here, the transformation of signals are always in a forward direction. That is why it is called feed-forward neural network. And the information is constantly feed-forward from one layer to the next. And this explains why this network is called feed-forward network. There is no connection among the perceptions in the same layer. Sometimes we call neuron as a perception also. So I hope this is very simplest kind of a topology of a neural network. Okay. So what are the application of feed-forward neural network? Simple. It is used for classification also, face recognition, computer vision, speech recognition. So if your problem is from these domains, you can use the feed-forward neural network. Advantage, less complex, very easy to design and maintain because there is no interconnection between the neurons of same layer. High to the noisy data also. Disadvantage. Nowadays, there is a lot of things are there going on in the market about the deep learning. So this network is not suitable to apply in the deep learning, right? So next we will learn about the recurrent neural network or feedback-bud neural network. So I request all of you please concentrate on this picture. So see this three kind of colors are available: input cell, the output cell, and recurrent cell. So let me explain you what is the meaning of this one. Input cell, input layer is there. Three kind of input is there. In input layer, 3 neurons are there. And like a feed forward, every neuron is passing its output to the neuron to the next layer. And next layer is what? Recurrent layer. Why it is recurrent layer? Though there is a one input layer, one output layer, in between two hidden layers is there. So what is the feature which is making it is a recurrent neural network? See, here the output of, see the second layer. Here output of this neuron is given feedback to this neuron. Exactly the same meaning. Giving feedback means what? We simulate something, we get the output, and the output is not as per our expectations. Then we feed back this output to the neuron to make the adjustment in the weights, to do some more mathematical calculation. So here feedback is available. That is why it's called feedback neural network or recurrent neural network. The first layer is typically a feed-forward neural network, followed by a recurrent neural network layer where some information it had in the previous step is remembered by a memory function and is as it is given as a feedback. So this is more complex kind of a things, and it may have a arbitrary topology also. There is no need to have a 4 or 5 layers also. We can add more layers also, or probably this neuron may have a recurrent feedback system, or this may not have. So this is a free topology kind of thing is there in recurrent neural network. All right. Application. This recurrent neural network is used for to solve the more complex problems. Text processing like auto-suggest, grammar checks, etc. Text to speech processing. This is suitable for that. Sentiment analysis. Translation. Advantage. Model sequence data where each sample can be assumed to be dependent on historical ones is one of the advantages. Used with the convolution layers to extend this pixel effectively. Though convolution neural network is not in your syllabus, but this is now primarily very useful in machine learnings, right? So if time permits, at the end of when we have a time, we will discuss about the convolution neural network also. Not today. Disadvantage. It may require a huge training time. The training of recurrent neural network is difficult task. I hope you understand advantage and disadvantage of neural network. As I told you, if one thing have a advantage, it have a disadvantage also. Neural network can perform tasks that is not always linear in nature. When an element of the neural network fails, for example, there are 5 neurons are there in a particular layer and one mathematical model of neuron is not working, then the neural network can still process the information. It still can work because it is a fault tolerant. And neural network learns and does not need to be reprogrammed. As I told you, we cannot say that we are not saying that it is programmed like a traditional machines. The knowledge is acquired or it is learned. It can be implemented in any application. What are the disadvantages? The training times. Even nobody can predict that how much training time is required to train the particular. This is very simple to understand. If child is there, you cannot predict just by seeing the child that how much training, how many days or hours are required to teach the English language to a particular child. Same thing happening over here. The architecture. What kind of architecture will be suitable to the problem? Again, by just seeing a problem, you cannot predict the topology or number of layers. That comes from the experiment itself, and requiring high processing time, because we are not aware about the training times. We are not aware about how much knowledge is required. So there is a possibility that high processing time is required, or lot of CPU cycles are required to train the ANN also.
Right, sir.
The application of artificial neural network. See, as I was discussing in the first two periods, that it is very, very important to understand the industrial application of the subject. Until unless as a student, we are not clear about the application of the subject, where we are going to apply this subject, then sometimes we get disconnected from the subject. So let us spend some few minutes over here, and your questions are also most welcome. Nowadays, neural network is widely used. I think a lot of buzzwords you heard about on internet also, when you can do the Googling also. The machine learning, deep neural network, convolution neural network. But those all things can be understood only when your mathematical background is sound, and if you are gone through the basics of neural network, basics of soft computing. All right. So aerospace is one domain or one industry which is widely using the neural network. Autopilot aircraft. I think you must be aware that when we are flying from the Delhi to New York, it's not always that the pilot is steering the vehicle, the plane always. So nowadays they fix the coordinates, and I don't know the complex nature of the algorithms there, but the autopilot facility is there. The pilot can put on the plane on autopilot. So when we are those kind of software has been designed, the concept of ANN is used. Aircraft fault detection. See, you can see this is a very, very when the aircraft is flying, and before the aircraft flying, the flight engineer has to be 100% sure that there is no fault in the aeroplane. So this is manually he or she cannot, even the more than one flight engineer cannot inspect the complete things. So it has to be some software is there, some machine should be there. So ANN is use this. Automobile industry is widely using automobile guidance systems. Military use of ANN. So my dear students, it is said that in couple of years, if the war happens, there will be cyber war, or probably man will be behind the scene and machine will be fighting the war. And machine is fighting the war, it means the intelligent machine has been developed. If we are saying the machine is intelligent, it means what? The human brain has been simulated till some extent in the machine. So it means the concept of ANN has been used. The weapons orientation, steering, target tracking, object discrimination, enemy info. The enemy plane is coming. Let's say we have to shoot a missile, and 4 or 5 aeroplanes or fighter planes are there in a space or in a sky. Then we have to identify which are our planes and which are enemy's plane. So there we can design a software by using the ANN. Signal and image identification. Electronics. See, chip designing, IC layouting is very, very critical task, because in every machines or everywhere, wherever there is embedded system, the ICs are used. Code sequence prediction, IC chip layout, chip failure analysis, machine vision, voice synthesis. ANN is widely used in electronics domain also. Financial. For example, the bank is giving a loan to particular area in a particular city, and for another area, the bank is not giving a loan. How it happens? So banks have a software which can kind of analyze the behavior of the customer of a particular area. On the basis of the behavior of I say behavior means what? Loan. Either banks are getting back their loans or not. So on the basis of different parameters, real estate appraisals, loan advisors, mortgage screening, corporate brand ratings, portfolio trading programs, corporate financial analysis, currency value prediction, document readers, credit application evaluators. So this is ANN is widely used in financial domain also. Industrial. See, power sector and the power grids are widely using the ANN to monitor the power grids or to automate the industrial plants also. There are plants in the world where completely automated, only 2-3 operators are operating the complete plant because it is software based. So when those software are designed, the concept of ANN or soft computing are used. Let us continue. Medical. Lot of research are going on. Cancer cells analysis, ECG and ECG analysis. For example, expert system designing. I'll say that medical field expert system. When I was discussing in the first class application of ANN, why we have to study the ANN, then we have discussed that just think about the scenario in rural India where doctor is not available and machine is there. So we can, given a symptoms of a patient as an input to the machine, and the machine can behave like a doctor. Probably we may not be said 100% confidently we have to give this medicine, but we can suggest something to the patient if the hospital is so far. So, telecommunication, image and data compression, automated information services, real-time spoken language translation. We heard that international arena, it's very common now. The Chinese president is speaking in Mandarin, and our Prime Minister of India is putting a microphone and getting a direct translation in Hindi. So it's very common. Software industry widely used, time series production, signal processing. Neural network can be trained to process an audio signal and filter it appropriately in the hearing aids. See how useful it can be. Control. ANN are often used to make steering decision of physical vehicles. Now we all know that the vehicles are coming, a lot of research are going on. Even there is a prototype in the market. A lot of car companies or software companies or hardware, other companies are coming in the market with automated vehicles. Anomaly detection. Just assume that be making a design of a new aircraft. And we have to simulate how this aircraft will behave, the structure of aircraft behave when it will be in the sky. So we cannot put all the structure on a sky. We have to design a software, and when we are designing those kind of a fault detection software, anomaly detection software, the concept of ANN is used. Okay students, so in today's lecture, we learn about the different topologies of neural network, different type of neural network. We touch upon the application disadvantage, advantage. So now I think we are equipped enough with a background knowledge and some mathematical definition of artificial intelligence. Thank you very much. In next lecture, we will discuss about the activation function and some basic other terminology. Thank you.